Hey everybody, today's video is going to be on equilibrium calculation. So I'm going to talk you through a couple of the general types of calculations you're going to see when you're working with equilibrium. And then I'll do some follow-up videos as we go through the remainder of the lessons. Okay, so this is number 39 from the textbook and from the homework assignment. So what I'm going to do is just kind of go through and talk to you how to do the problem. So here we go. What we're looking for here is we're looking for whether the reaction is at equilibrium, and if it's not at equilibrium, what we need to do is figure out which direction it's going to go in. So really what I'm going to be doing is I'm going to be calculating for the quantity Q as opposed to K. Now they give me the equilibrium constant, which is going to be the K value here. That's what this is. Now this is the value that you have when the reaction goes to equilibrium. When it goes to equilibrium, it's the ratio of the products to the reactants. You've got to remember that K is your ratio of products to reactants at equilibrium. That's the key, is that this is at equilibrium. This here, Q, is a test that we do to see if the system's at equilibrium. So if Q is equal to K, then we say it's at equilibrium. If Q is greater than K, okay, and Q is going to be the same thing, by the way. Q is going to be your products and reactants, but under the conditions that you're given. So that would be these conditions here. We don't know if those conditions are currently at equilibrium. So we compare Q to K. Now if Q is greater than K, what that's telling me, if this value here, Q, is bigger than my value K, that I have more products than I'm supposed to have at that particular point in time. So the reaction will shift to the left and will react to the left. That's what shifting is. Shifting means that the products, in this case, are going to decompose back into my reactants if Q is greater than K to alleviate that excess amount of products that I have. Now if Q happens to be less than K, then I'm going to have the opposite happen, because if Q is lower than the value of what K is, then I don't have enough products yet, and therefore the reaction has to shift or react towards the product side and produce more products and use up the reactants to try to approach the value K until it gets to, of course, K. So let's just take a look at the information. So I know that I'm calculating Q, and then I'm going to compare it to K because I'm trying to figure out if the system's at equilibrium. All right, so the conditions that they give me, they tell me that the volume is 1 liter. So I want to keep that in mind because they're telling me that I have moles. Well, in order to find the concentrations of this, right, which would be the moles per liter, I need to go ahead and divide these out. Now this works out nice and easy because of the 1 liter. All of these values can easily, quickly be converted to molar values, because 1 divided by 1 is 1. 0.1 divided by 1 liter is 0.1, and the same thing is true for this one. So these are all really molar concentrations already based on the scenario. So I go ahead and I calculate Q. So I plug into my equation. So I write the equilibrium expression just like I would for K. So if I was just calculating like K, I do the same thing, but these are under the current conditions that I have. So H2O, and just double check that H2O is a gas, and it is. So everything's a gas, so I don't have to worry about getting rid of solids or liquids or anything like that. And then Cl2, dichlorine monoxide. Plug in all my numbers. I'm just going to give you the answer. Comes out to 100. Now, just like I said before, we need to compare Q to K. Now, Q is 100 and K is 0.09. So clearly, Q is greater than K. Now, instead of memorizing all the stuff that I just told you, this being equilibrium, this shifting to the left and this one shifting to the right, just figure it out like I did initially. Since I have too much in the way of Q is too big, I have too many products, so therefore it shifts to the right in the shifts left, my fault, got distracted there. So it shifts left because the reaction is going to have too many products at the conditions that I have. So we have to alleviate that by shifting and producing more reactants, okay? So as the reaction progresses, it's going to remove the products and increase my reactants. Okay? All right, so let's take a look at another example. In this example, what we're going to do is we're going to try to find the value for K. So we need to look for K. So K equals is what we're looking for. Okay, so I identify what I'm looking for here. Now with the reaction here, I've got the sulfur trioxide, and that's a gas. Okay, now what they're telling me here is they're giving me at a particular temperature, okay, that's fine, it's not that important right now, that I start with 12 moles of the sulfur trioxide. So that is the initial amount. That's how much I'm starting with, and it's put into a 3-liter container. So I've got a volume equal to 3 liters, and I need to find my concentration of the sulfur trioxide, which would be to take the 12.0 moles over 3.0 liters. In this case, I'm going to have sulfur trioxide. Now, these are the initial, right? This is my initial amount that I have. Is going to be equal to 4 molar. Okay, so divide that out. I end up with 4 molar. So initial, change, equilibrium. So what I'm going to do is I'm going to plug in my initial amount of sulfur trioxide, which is 4 molar. Now they don't give me any sulfur dioxide, and there's no oxygen given, right? So they don't tell me anything in the problem, so I would assume that those are not being added. So they're just telling me what they're placing in there, and then they let it go to equilibrium. Okay, so the reaction goes to equilibrium, and at that point, I then have a certain amount of sulfur dioxide gas, and now this is an equilibrium amount. 1 molar of the sulfur dioxide at equilibrium. So I could minus 2x, I forgot to put the 2 here, forgot the x, and plus 2x plus x. I'm just using the coefficients, okay? Now, I know that at equilibrium, I end up with this amount of sulfur dioxide. Now, you should hopefully remember from doing problems in the ICE table, or not the ICE table, with the BCA table in stoichiometry, that if we have this set up, we can actually go ahead and calculate the value for x by knowing that 0 plus 2x equals 1 molar. So therefore, I can quickly calculate what x equals. And I think you guys can do the math here. If not, then just set that up. 2x equals 1 molar, and solve for x, which comes out to 0.5 molar. Therefore, if this is 0.5 molar for x, 2 times that is going to give me 1. 3 minus 1 gives me, 4 minus 1 gives me 3 molar. Then over here, this is just going to be 0.5 molar. So now I figured out my value of concentrations at equilibrium by just knowing one of the values. So now I go ahead and I plug in, and I just plug into the equation. In this case, I'm going to plug in 1. And when I do the calculation, put all of that into my calculator, I end up with a value of 0.0556, which if you use the significant figures, I have 3 and I have 2. I should have 2 in my final, 0.056. So that would be my value for K. And since K is such a small value, I'm really going to be favoring the reactants in this case and not the products, since K is so small. Okay, so those are some intro to equilibrium calculations, and hopefully if you have any questions, I'll be able to answer them in class. Thanks a lot, guys.